All right, so we'll start in on exponential and logarithmic equations here. Now this is still sections 4.3, 4.4, and 4.5, and I guess I have 2 pages of notes with this, and once we're done with this, then we're done with those sections there, okay? So let's start off with logarithmic equations first, and I'll just show you some examples. So in this first example, suppose I want to solve the equation log base 3 of 4x minus 7 equals 2. Okay, solve for x. Well, I use the definition of a logarithm. So x equals a to the y. The input expression is 4x minus 7, so that's going to be all alone on the exponential. A is the base, so 3 would be the base, and 2 is the y value. Okay. So 4x minus 7 equals 3 squared. 3 squared is 9. And by using that definition, I get rid of the logarithmic notation there, which is good. 3 squared is 9. So then if I add 7, 4x equals 16. Means that when we divide both sides by 4, we get 4. Okay? So I think 4 is the answer. Now, there's only 3 equations in all of algebra where you have to check your answers. We've seen 2 of them already, and that was back at the end of chapter 3. When you're solving a rational equation or a radical equation, you have to check your answers because you sometimes end up with extraneous solutions. And also, when you solve a logarithmic equation, you can sometimes get extraneous solutions there. Okay, so let's go ahead and check this. We think that x is 4. Okay, so I got log base 3 of 4 times 4 is 16, minus 7 is 9. Log base 3 of 9, well, 9 is the same as 3 squared, right? And I can bring the power of 2 out in front. So I got 2 times log base 3 of 3. Log base 3 of 3 is 1. So I get 2. 2 is what I had to get. Okay, so x equal 4 is the right answer. Okay, go ahead and circle that. Now, for whatever reason, if I were not getting 2, then I would cross off that number, and I would just have no solutions then. Okay. Let's try this example next. So we got log base 2 of 4x equals 2 minus log base 2 of x. Okay, let me add log base 2 of x to both sides. And using law 1, I'm adding 2 logarithms. They have the same base. So I'm going to get a single logarithm out of that by multiplying the inner terms. 4x times x is 4x squared. So I got log base 2 of 4x squared equals 2. And then let me use the definition for a logarithm to get rid of the logarithmic notation there. By the way, usually when you're solving a logarithmic equation, usually you'll have to use the definition of a logarithm at some point in the process. So the input expression is 4x squared. The base is base 2. The y value is 2. So 4x squared equals 2 squared. 2 squared is 4. When I divide by 4, x squared equals 1. And then when I take the square root of both sides, x would be plus or minus 1. Don't forget about the plus or minus there. And so I got to check those. Okay. Well, negative 1 is no good because I can't take log of a negative number. Right, if I plug that back in the original equation there. So throw away negative 1, that would be an extraneous solution. Now I want to know if 1 is going to work out. If I plug 1 into the original equation, I got 2 minus log base 2 of 1. Log base anything of 1 is always 0. So 2 minus 0 is 2 on the right. Do I also get 2 on the left when x is 1? Well, log base 2 of 4, 4 is the same as 2 squared. So I got log base 2 of 2 squared. The power of 2 can come out front. I got 2 times log base 2 of 2. Log base 2 of 2 is 1, and 2 times 1 is 2. Okay, so 2 equals 2, that's true, right? So 1 would be the only answer there. Okay. Here's another example. So how about what if we had the ln of x plus 1 equal 2 times the ln of x minus 1? Okay. Let's first get rid of the 2 that's in front of that logarithm there on the right. Now I know that 2 can be pulled up as a power of the inner part, right? I'm using law 3 in that process. So go ahead and do that. You got the ln of x plus 1 equal the ln of x minus 1 squared. Now I got a logarithmic equation. There's logarithms on both sides and they have the same base. And nothing else is in front of those logarithms. So I can remove the logarithmic notation and set the inner terms to be equal. X plus 1 would be equal to x minus 1 squared. X minus 1 squared, that's the same thing as x squared minus 2x plus 1. Okay, and the nice thing about this is now I don't have any logarithm involved in this anymore. And if I solve this equation here, let's subtract 1 and subtract x. When I subtract 1, the 1's are gone. And when I subtract x, I'll have x squared minus 3x equals 0. X is in common of those two terms, so let's go ahead and factor that out. And we have x times x minus 3 equals 0. That means that x is 0 or x is 3. And I got to check the results. So 0 is no good because if I plug in that number, I'm taking log of a negative number. You can't do that. You can't take log of 0. You can't take log of a negative. So 0 would be an extraneous solution. Okay, and now I want to know if 3 is going to work out. Well, same deal, so I'll plug that number into the original equation there to check and see if I get a true statement. When x is 3, you get the ln of 4 equals 2 times ln 2. The 2 can come up. And ln 2 squared, that'd be the same as ln 4. ln 4 equals ln 4, that's true. So x equals 3 would be the only answer there. Now, again, when I'm checking my answers, I always plug in the numbers into the original equation. Nothing that's been simplified beyond that. Okay, so like when I'm plugging 0 in, I'm plugging that in up here. I don't want to plug 0 in, you know, like right here, because 0 minus 0 is 0 and 0 equals 0. That's true. But 0 is not going to be kept because this equation is not my original equation. It's up here. Okay? So always plug in the number into the original equation. Nothing that's been simplified after that. Okay. How about what if we had log base 4 of x plus log base 4 of x minus 3 equals 1? Solve for x. So let's see. I'm adding two logarithms, and they have the same base. Nothing is in front of those logarithms, right? So let's use law 1, and we'll get a single logarithm out of that by multiplying the inner terms. So I'm going to have log base 4 of x times x minus 3. That's the same thing as log base 4 of x squared minus 3x. And that'd be equal to 1. Now from this point, you've actually got two options to continue to solve. Okay? Probably what most people would do is they would use the definition of a logarithm. And they get rid of this logarithmic notation there. And so if we do that, x squared minus 3x, that's the input, so that'll be all alone on the exponential, equals the base is 4, and the y value is 1. So I get x squared minus 3x minus 4 equals 0. I'll mention another option that you can consider just after we get the results here. This is going to factor as x plus 1 times x minus 4. And so x is -1 and x is 4 are the two possible answers. And I'll need to check those, right? So x equals -1, that's no good because I can't take log of a negative number. By the way, one thing to mention here. Just because x is a negative that doesn't mean immediately I throw that number away. You can sometimes have a negative answer with logarithms, okay? We're just saying that when you plug that number back into the original equation, you can't take log of a negative number. So when I plug -1 back into the original, I get -4 here and -1 here. That's no good, okay? If I was plugging -1 into the original equation and both those values were positive, then I'm probably going to keep -1, okay? So it just depends, but be sure that you're checking the result there. If x is 4, I got log base 4 of 4, that's 1, plus log base 4 of 1, log base anything of 1 is always 0. 1 plus 0 is 1. Okay, so 4 is going to be kept. If 4 didn't work out, then I cross off 4 and I write no solutions, right? Like I have no idea what numbers I'm going to keep or lose, at the beginning of the problem until I solve the problem and check those, okay? But the point, again, is to make sure that you're checking these. So let me come back up to here at this spot. And I mentioned that there's 2 options to continue to solve. So what we did was we used the definition of a logarithm, and we got to this next line here. Okay, that's great. That works. Okay, here would be another way to do the problem. So I got log base 4 of x squared minus 3x equals 1. 1 is the same as log base 4 of 4, right? So now that I have a logarithmic equation where there's logarithms on both sides, I can remove the logarithmic notation there and set the inner terms to be equal. And I would have on the next line, x squared minus 3x equals 4. That's exactly what I got over here when I use the definition of a logarithm. Okay, so whether you're going to use the definition of a logarithm or get a little fancy with things, the next line is still going to be the same regardless of that, okay? All right, let's try another example. And I'll show you one more example of solving a logarithmic equation, and then in the next video we'll turn our attention to solving exponential equations. Okay. What if I want to solve log of 11x plus 9 minus log of x plus 3 equals 3? So I'm subtracting these 2 logarithms. So let's use log 2 and get a single logarithm out of that. We'll divide the inner terms there. And so I got log of 11x plus 9 over x plus 3 equals 3. Okay, and I'd say from this point, when we get rid of the logarithmic notation, we'll use the definition of a logarithm to do that. So 11x plus 9 over x plus 3, that's the input into the logarithm. The base is base 10. So I'm going to say equals 10 to the y value is 3. 10 cubed is 1,000. And so then on the next line, let me multiply both sides of this equation by x plus 3. I'll have 11x plus 9 equals 1,000x plus 3,000. Okay, and how about anything involving x? Let's get that on the right, and anything not involving x, we'll get that on the left. Okay, so with that said, 9 minus 3,000, that would be negative 2,991. And then I'm also subtracting 11x from both sides. 1,000x minus 11x is 989x. Okay, so I got 989x equal negative 2,991. When I divide both sides by 989, negative 2,991 divided by 989 as a decimal would be approximately negative 3.02. I got to check that. So is that number going to work? Well, no. Now, I'm not just throwing that away because that's a negative. Don't do that. Okay, you got to check it. So is it true that if x is a negative 3.02, like am I going to still get 3 there on the right? Well, negative 3.02 plus 3 is negative 0.02, and you can't take log of a negative number, right? I would also get a negative number right here too. So negative 3.02, that's the only possibility, and it didn't work out. So go ahead and throw that number away, and there's going to be no solutions to this equation. Okay. So that is some information on solving logarithmic equations. And in the next video, we'll look at solving some exponential equations. So here's the other handout here, and here's the homework problems. But now we have already started to do, some problems where we're solving exponential equations. And the goal, first thing is that I try to get the same base on both sides. I can't always get that. Okay, so there is more to know here. I'll explain how to do that in the next video, and then we'll be done with 4.3, 4.4, and 4.5. Okay, so all right, we'll go ahead and stop the video right here.